Okay, before we start with exercise 1.5, let us learn to multiply when there is a root over, and also we'll do the same thing for addition and subtraction when there's a root over. Okay, so have a look at this example here. So when you look here, can you see that we have two root 3 and root 5, right? So how do we multiply when there's a root over? So in order to help us to understand easier, I have written here what? Can you see that this we'll just take it to be like this. This 2 and 4 are outside the root, right? And then this 3 and 5 are inside the root. Okay, so how do you multiply? Pretty simple. You just have to multiply outside, and then inside. So when you look at the outside first, 2 is here, 4 is here, right? So 2 4s are, we're going to get 8. And then like I said, inside, right? So 3 5s are 15. Okay, once again, remember, outside you will multiply, and then inside you will multiply. So that is how we will multiply when there's a root over. Now let's go to how to add or subtract when there's a root over. So have a look at this a and b. Of course we can see that they both have root, right? One is root 2, root 3, and then same thing here. I'm taking the same example, okay? But here we cannot add or subtract. All right, the reason being that when you look at the under root, whatever is inside the root, this root 2 and root 3, 2 and 3, they are not same. Okay, so we cannot add or subtract. We'll just have to leave it as it is. But now let us look at our example C and D. When you look at example C, can you see they have the same under root, root 5, root 5. Okay, only then you can add or subtract. Even when you look at example D, we can see that they have the same under root, right? Root 5 and root 5. So once again, only when the under root are same, then we can either add or subtract. So how do we add? We just have to add the outsides. Okay, 12 plus 4, 16, and then root 5. Same thing again, 12 minus 4, 8. We're going to get 8, right? And then the answer will be 8 root 5. All right, now let's go back to solving the questions. So 1.5, question number 2.1. Simplify each of the following expressions. Okay, so how do you do this? You can already see the question is here. Okay, so I've written a solution here. So what does this mean? This means that we'll first have to take this 3 and then multiply this 2. All right, once we're done with that, we'll take this plus root 3 and then multiply the whole thing again. So as you can see here in this step here, right, 3 is going to multiply both of them, and then root 3 is also going to multiply both of them. So how do you multiply? 3 2s will have 6, right? And then 3 into root 2 will have 3 root 2. Okay, because remember, this is when we look at this 3 root 2, 3 is outside, and then what? 2 is inside, right? So here we can't do anything much. Remember here 1 is 0. Okay, so when it comes to multiplication, remember what I said: inside, outside, right? But here 1 is outside, the other is inside, so we can't multiply them. Okay, you just have to write it as there. So it will just be simply 3 root 2. All right, you can already see here. Let's go to the next. Then we're going to multiply once again. When you look at these two, same thing, right? Root over 3 into 2 we have. One is outside, the other is inside. We cannot multiply them, okay? Like the rule says, outside, inside, right? So you just have to leave them as it is. So you can see here 2 root 3. But next, when you look, when I multiply this 2, it is root 3 into root 2. Inside, right? So we can multiply these 2. So we're going to get here root 6. Let's go to the next. Once again, the same thing. This 3 will multiply both of them, and once again this root 3 will multiply both of them. Okay, you can already see from here. Then 3 3s are 9. Then minus is there, so write down the sign. Then 3 into root 3, we're going to have 3 root 3. So the next will be what? This root 3 multiplying both of them again, right? So root 3 into 3, we're going to get 3 root 3. Then the next we have root 3 into 3, which is going to give us what? If you multiply root 3 into root 3, inside, right? So I'm going to get root 9. But we know that what? Root 9 is a square root of 3. All right, so here for this you can see that we get here minus 3. And when you look here, can you see that this is minus root 3 and then this is plus root 3? So we can always subtract both of them. Okay, then 9 minus 3, we're going to get 6. So here there's another way of solving it. Okay, that is, if you know this formula, a plus b, a minus b. All right, so when you look at it again, a plus b, a minus b. This is a, this is b, this is a, this is b. So what happens when we have it like that, a plus b, a minus b? We simply use the formula a square minus b square, right? So here a is 3, right? So a square, and this is our b, so b square. So you already know 3 square is 9. Now what do we have here? We're having here what? Root 3 the whole square. right? So this square and the root will get cancelled, and we're going to have 3, and then we're still going to get the same answer, 6, right? 6 and 6. All right, let's do one more. So here now we have what? Root over 5 plus root over 2 the whole square. Okay, so we're going to expand this in the formula a plus b the whole square. So what? So this is our a and this is our b, and we have the whole square. So the formula states what? A square plus b square plus twice ab, right? So this is our a square, then this is our b square plus twice ab. Okay, so once again, root over 5 the whole square, this square and the root will get cancelled, so we'll have here 5. Same thing for root 2 the whole square, you can cancel the square and the root, we'll have here 2. And now this portion here, you can see that 2 are inside and 1 is outside, right? So remember, inside, outside, outside. So outside just 2 is there, so leave it as it is. But here inside, 2 5s are, we're going to get here 10. Then you can add this to 5 plus 2, 7, and then we're just going to be left like this. Like I said, we can't add these two, okay, because they don't have the same under root.